turn to page 56 because that's a blank page. And on page 56, this was an exam question, a little controversy. Sorry. So I'll get you to write this down here. I'll turn off one light so you can see a little bit better. This was on an exam maybe 4 years ago. And there was controversy about the question after the exams. Like an exam's like any good sporting event final. There's going to be some controversy, talk shows talking about it afterwards. Same thing with this exam question. Teachers were angry, thought it was unfair, but we'll get into the controversy after we do the question. It also was on a non-calculated part. So I'll give you some time to write it down first. So first I'll give you a lesson on how to draw three-dimensional boxes pretty easily because it's super helpful. We've got a box in the shape of a rectangular prism. So what I do is I start off by drawing a rectangle that'll be one side of the box. Then to make it three-dimensional, go from one corner and pick some angle and draw a certain length. Then whatever your height of your box was, this line right here, I'm going to replicate it, same height there. That lets you draw this side of that box nicely. Whatever length you drew there, you copy that on this side, and then straight across. And you've got a nice three-dimensional box. We know the side lengths are x, x plus 2, and x plus 10. So we draw our picture, write a function, the volume of x. Well, that's length times width times height. So we've done the second sentence there. And then if you know the volume is 96, find the dimensions of the box. So we know the volume is 96. That means I can replace the volume with 96. And we get this equation. Now, this is unfortunately where the controversy begins. Because this is on the non-calculator part of the test. Most students were probably pretty smart in saying, do you think the answer could be something like 2.5839? No, it's non-calculator. It's going to be a nice number. So what did students start doing? They just started trying some nice numbers. Does 1 work? No. Does 2 work? Yes. Okay. So guessing and checking, they got x equals 2. So this is 2, this is 4, this is 12. They're done the question. They say, I figured it out. And all those students got 2 out of 5, or maybe 3 out of 5 on the exam. And teachers were mad. They're like, they got it right. They used this, like, based on what they have here, they used a good strategy. And yet they only got 2 out of 5 or 3 out of 5 on the exam. And people were mad because they thought that was unfair. Okay. So the exam argued that because it said all possibilities, how did that student know there wasn't any more? In order to find all possibilities, you would need to solve this algebraically. And one of the things you will see on future exams after this one, as a result of this controversy, they now say, solve algebraically, which takes out guessing and checking. Guessing and checking is not an algebraic method. So even though we know the answer now, let's look at how to get 5 out of 5 on this question if you were solving it algebraically. Okay, first mistake student made is like, oh, it's already factored, but already factored only helps you if the other side is 0. And because the other side is 96, you would actually have to, step 1, multiply this all out. Pick any two. I'm going to pick those two to multiply out first. This will give me x squared plus 12x plus 20. And now I can multiply by the x, and I would get x cubed plus 12x squared plus 20x. And if I wanted to make it equal to 0, I'd have to move the 96 over. In order to solve this, I need to factor. And the nice thing is, because we guessed and checked, we already know that 2 is the right answer, which means that x minus 2 would be a factor, which means in synthetic division, I could put a 2 outside, bring the 1 down. Oh, we'll have to continue this tomorrow.